Watch the previous videos, because if you didn't, these might be a little difficult to actually grasp the idea. But with that being said, let's just start with the simplest of simple examples of cyclization. So H plus is a cyclization. If you see H plus, know it's most likely going to be a cyclization, especially if you have OH on the ring and then a ketone slash aldehyde. And how these work is the lone pair from the ketone or the aldehyde will actually grab the H plus, and that will then give you your intermediate, which I don't actually have enough room to draw this out step by step, but I will draw that with a red bond. And of course, then we would have a positive charge on our oxygen, and then we can actually resonate this over, not over, my bad. And then this oxygen can come in and attack here, and that will then form a cyclic product. So to do this, just number from the oxygen that's that's attacking the open orbital to the ketone that's becoming, or actually aldehyde that's becoming open. Know you now have a 6-membered ring. Put your oxygen at that one spot, then just count 2, 3, 4. We have methyl. 5, 6 is where we have our newly formed OH, and that's your product. So not too hard at all. There's actually 4 other ways to form cyclic products: the H plus way, which I just showed you, the Dean-Stark way, the Grignard, and the Pph3, and we'll just go through each of those real quick. So the Grignard cyclization. If you watch my previous video, you understand how Grignard reagents react with molecules and the mechanisms behind that. So we're not going to actually go through that, but we are going to look through at the cyclizations that occur with Grignard reagents. So how does this occur? Well, the first step is when you react this with Mg, of course. As you know from my previous videos, it forms this product. However, if you remember the Grignard mechanism, this can move upwards, resonate upwards, and then this can actually then bond at that open orbital. And the one thing I do want to note for the Grignards, unlike the H plus where you actually count from the oxygen, do not do this. Don't go 1, 2, 3, 4, 5, 6, and think you have a 6-membered ring. You do not have a 6-membered ring, okay? Count the actual bonds when you're doing the Grignard. So 1, 2, 3, 4, 5. You are going to actually have a 5-member product, which looks like this. That's your final product for this Grignard cyclization. So once again, just want to note, do not do the counting method with the Grignards, because that would give you a 6-membered ring, and that would be incorrect. Count the actual bonds, 1, 2, 3, 4, 5, and then just attach the Mg over, like the old Grignard mechanism I showed you in the previous videos. And that's how you do Grignard cyclizations. Pretty simple. Moving on to the Dean-Stark. The Dean-Stark, all the Dean-Stark does is it actually makes water leave. So here we could actually have either this leave or this leave as water. So basically how that works is a hydrogen will come in and attack one of these oxygens, making this oxygen positively charged. So then once that occurs, it can actually then leave, giving us an open orbital here. And then the lone pair from this oxygen can then attack, but we don't have to resonate this. We don't have to do that in order for it to attack. The orbital's already open since the OH left as water. So then we just once again count from the oxygen. 1, 2, 3, 4, 5, and 6. Draw out a 6-membered ring. Draw in your oxygen there. The second spot I have methyl. Third spot I have isopropyl. Fourth spot nothing. Fifth spot nothing. Sixth spot I have my ketone. And let me just go back and double check. 1-spot oxygen, check. 2-spot methyl, check. 3-spot isopropyl, check. 4-spot nothing, check. 5-spot nothing, check. 6-spot ketone, check. Correct. That's your product. So as you can see, it's basically just numbering and keeping track of all of your substituents, and that's how you do these. The next one, H+. Now this one's a little tricky compared to the other one, because you think, if you watched my previous video, you'd probably think this is the product you should obtain. However, this is not correct. The product you would obtain with this, and we're actually going to go through the mechanism with this real quick, because this one is a little trickier to actually grasp. If you watched my previous video, you understand this mechanism. And the first step is this. However, once we resonate up, the oxygen can actually come in and attack. 1, 2, 3, 4, 5, 6. Draw in a 6-membered ring. On the second spot, we have a methyl. Third spot, nothing. Fourth spot, nothing. Fifth spot, nothing. Sixth spot, we now have a methyl and an OH. And do remember, there is actually an H on this oxygen, so it is positively charged. We can then, though, if you recall from the other mechanism, that resonates in. This oxygen grabs that hydrogen, oh my bad, and then that will take us to our next step. Which looks like this. So this can now actually leave, leaving us with an open orbital. And you have to remember, we have excess MEOH still available to us. So that MEOH can then attack once again. If you remember from the previous video, that generic base can then come in, grab that hydrogen, and then give us our final product. Which is going to be this. And this is a single bond. I apologize. It kind of looks like a weird thick bond, but that is a single bond. And that is your product. I hope that makes sense. If you watched my previous video, you'd understand why that occurs. But basically, yeah, that's the mechanism. It's kind of hard to explain without following that mechanism, and I will label each one of these steps so you can follow along. 1, 2, 3, 4, 5. And the only reason it's not OH for this cyclization with the H+ is because we do have that MEOH there. So there is going to be an OME, or it could be ETOH, or any of the protic solvents like that, or alcohols, I should say. But that is the mechanism. So moving on to the Pph3 mechanism. If you watched my Wittig reaction video, which I highly recommend watching, you'd understand that the first step of Pph3 is setting it up. So that would then give us something. Once again, it should be attached to the P, but I don't have enough room to attach to the P. So that's why I'm doing it this way. That will give us something that looks like this. There's Br minus floating around in there. And now then if we react this with TBUOK or NUBLI, if you recall, that looks gross. You would get this product. There's a double bond there to Pph3. And now then, we just do a Wittig reaction on our own product. And once again, this is one of those ones where you really don't want to count the carbons. It's kind of hard to count because you might get the wrong product. Count the bonds. So 1, 2, 3, 4, and then these will attach to each other right here. I'll actually highlight those in blue. Oh, that's not going to work. Those will attach to each other and form a double bond. So your product would actually look like this, because this double bond right here and this double bond are coming together to form a single double bond together. And then we have 1, 2, 3, 4 other bonds, and then the one new double bond. So that equals 5 total bonds. And then also just keep track of your substituents. Your substituent right here would be attached to the double bond. So I have it attached to the double bond right here. So this is your product. Pretty simple, just keeping track of the cyclizations. I highly suggest just practicing these because they can get a little confusing. And it's not that they're confusing, the mechanisms are pretty simple and how they actually attach is pretty simple. It's just kind of keeping track of everything can be a little complicated. But with that being said, that is the Wittig cyclization. The final cyclization, which is, we already technically did this cyclization, it's H+. However, this is forming double rings with H+. So you can form more than one ring. And I'll show you how this works. So first step again, the hydrogen attaches. Then we would resonate this up, and that would leave this open. And that would give us this. Now choose what one you want to attach with first. It doesn't really matter because they're both going to end up attaching. So 1, 2, 3, 4, 5, 6. We are going to form a 6-membered ring. Put my oxygen there. At the second position, I have an ethyl. Third position, I have nothing. Fourth position, nothing. Fifth position, nothing. Sixth position, I actually have OH. And then we have this guy right here, which is 1, 2, 3, 4. 1, 2, 3, 4. Now count my carbons though, just to be safe. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then at the second position, I actually still have that OH. And I apologize, these can look a little sloppy, but this is what it would look like. Now then, we can actually have the OH leave from here, since we do have excess H+, making this positive and turning this OH into a leaving group. So then it can actually leave, opening up this orbital, and then this hydrogen, or not hydrogen, oxygen can come in and attack there, and that would then form 1, 2, 3, 4, a 5-membered ring attached to that 6-membered ring. So draw out your 6-membered ring, I'll actually try and make this one a little cleaner. Like that. And then draw in your substituents. Just draw in that original ring. And now then just boom. 1. Oxygen. I didn't draw that nice enough. Like that. There's my oxygen. And then I also have right next to it, a methyl, like that. So now then count. 1, we'll go 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. 1. I actually number this the wrong way. 3, 4, and then 5. This should actually be on the 5th position. I number this the wrong way. And then that is your product. Oh, crap. Once again, kind of hard to explain with words. It's easier to show how it actually occurs, and that's how it occurs. And I hope you understand. This is your final product. And with that being said, I hope you understand how these cyclizations occur, and I hope you guys have a wonderful day. And I apologize if I'm going a little fast with all this. There's just so much information we have to get through in so little time. But have a wonderful day, and if you have any questions, please leave a comment. And don't forget to like, follow, and subscribe.